unraveling the mystery of Proxima Centauri. You won't believe what we found. Proxima Centauri is the closest star located to our solar system, and yet it seems that it is so far away. In this video, we will talk about why Proxima Centauri inspires so many dreams from scientists, so stay tuned. But before we continue further, I would request you to subscribe to our channel. Thank you. But why does Proxima Centauri seem so far away? Even equipped with ultra-modern technology, it would take thousands of years to reach this star, which begs the question, if human beings will ever have the technology to make that interstellar trip. Located 4.2 light-years away and situated in the Centauri star system, believed to have conditions comparable to our own and considered to be ideal for hosting life, this exoplanet has been theorized to be the twin of Earth. Making the trip to this planet, then, should be the highest priority for our astronomers and space scientists. However, the problem is that even with our sophisticated technology, we have not been able to travel outside of our solar system. Technological limitations are so rife that humans have not been able to set foot on any other planet other than the Moon. So, one thing is for sure, it will take a long time before humans will have the capacity to make it to Proxima Centauri. So, let's try to understand the technologies that we do have, and which theoretically at least can be used to cover these distances. The fastest probe that we have been able to produce is Voyager 1, which travels at a speed of about 17 kilometers per second, which amounts to roughly 540 million kilometers per year. Pretty impressive, no? The issue is that Proxima Centauri lies some 4.2 light-years away, which equals 39,740 billion kilometers. At this rate, it would take Voyager 1 about 76,000 years to reach Proxima Centauri. If we do manage to cover almost 10,000 kilometers per second, then we can hope to reach Proxima Centauri in 130 years. The issue with this equation is that humans normally die before the age of 100. If somehow we increase the speed to 25,000 kilometers per second, the flight is reduced to 50 years, which sounds plausible at least on paper. Now, since these speeds cannot be achieved by conventional propulsion systems, which have been used in Voyager 1, we should be looking for alternative propulsion solutions. Why are we looking for alternative propulsion solutions? Because chemical propulsion, or ordinary rockets, can produce a thrust of 3,000 kilometers per second, which is 1% of the speed of light, if 1,026 of hydrocarbon fuels are burnt. This means that for this entire ship, the ship would have to consume fuels, which will weigh more than the Earth itself. So what are these alternative solutions that we keep coming back to? Ion and nuclear thermal propulsion. Ionic propulsion, or electric propulsion, is used in many propulsion systems. Nuclear thermal propulsion systems have also been used, but all of these technologies have been limited to travel within the solar system. An alternative engine is Vasser, which is proposed by Astra Rocket Company, which has a former Costa Rican astronaut, Franklin Chang, at its helm. The project aims to develop a plasma ion engine, which will have a cheap and efficient power source. This project actually makes it possible to travel to Mars, and the journey itself would be 10 times faster than conventional means of travel. Now, let's use Vasser to solve our conundrum of traveling to Proxima Centauri. Calculations show that it would take 2,200 years to reach our destination, which is better than conventional technology, but is still far off from our desired goal. The original Orion project, which proposes nuclear propulsion, is also pretty much out of the picture. It would use nuclear fusion, and the spacecraft itself would have massive dimensions, which would make it nearly impossible for manufacturing it in the first place. But even if all the technological and manufacturing challenges have been successfully met, it would still take 150 years to reach Proxima Centauri. Another proposed solution is to use a solar sail, which has been adopted by a design used by the Japanese Space Agency. The solar sail is essentially a parachute-shaped structure, which would utilize the radiation pressure of sunlight. However, this technology still needs to be combined with other systems to achieve that desired velocity. One suggestion is to use solar sails in conjunction with nuclear propulsion mechanisms, because using solar sails alone would take 2,000 years to reach Proxima Centauri. Yet another proposal is to use laser sails. Laser sails utilize energy beams to propel the probe. These lasers are extremely powerful. They'd have about 25 gigawatts of power, which will have the potential to cross that distance in only 40 years. considering that the Voyager 1 has taken 45 years to leave the solar system. This proposal seems to make more sense. The concept has been in development under the Breakthrough Initiatives programs and is called the Starshot technology. It aims to develop solar sails and microspacecraft materials, which will cover distance somewhere between 20 to 30 years. But it should be remembered that this technology is still in development, and it will probably take a lot of time before this technology can even be tested. Space engineers and astronomers think that it would take almost 2 decades to come anywhere near to what they have drawn on their blackboards. Will we ever be able to overcome this challenge? Feel free to comment below. Please give this video a thumbs up. Thank you for watching till the end, and see you soon in the next video. Cheers!